Hello, welcome. We will wait for some scatterers to filter in as we go, but we will get started in the thoughtfulness of time here. We have two presentations, both kind of chloride focused. We'll do presentation, and have a longer question session at the end. First off, we have Allison from Wisconsin Saltwise. Up second, we have Mike. I'll do his introduction now so we can hand off easy from one to the other. Allison Madison is the program manager for Wisconsin Saltwise. She is, from my perspective, the face of chloride management in Wisconsin. Mike is the deputy agency director and director of environmental resources planning at the Capital Area Regional Planning Commission. I am personally writing a chloride management plan right now, and Mike was one of the first persons that I called and asked him what his experiences have been previously to help me kind of figure out what I'm about to do next. So hopefully, again, we'll get some good information here, which I'm sure we will, from them both for these talks. And again, we do have a virtual audience. We'll be taking questions through the chat, and we'll get into those at the end after both talks. Sound good? Okay, let's go.
All right, and volume coming through. Okay, great. Welcome everybody who's here in person. Thank you for choosing to spend the last part of your afternoon with Mike and myself, and welcome everybody virtually. So I am Allison Madison, located in the Madison area, working statewide around salt pollution and salt pollution reduction solutions. And there are quite a few of them. So we're gonna share a little bit of bad news first. We got a problem, but also a lot of amazing things are happening. So we'll focus on those too. And I think you were gonna help me, thank you. It should work now. All right, so Saltwise is a coalition of organizations from all across Wisconsin. I see some of our members who are really active in this work here in the room, so thank you. We're always looking to broaden our partnership because Saltwise really is made up of people. Programs are people, right? And so we need people to drive this all across the state. And a big shout out to the Fund for Lake Michigan, one of our primary funding partners. So salt, when we talk about salt, there are a lot of different salts, right? But the main salt we've identified here is sodium chloride, ending up in our drinking water, in our surface waters. Primary sources of that, can you shout some out? Where does the salt come from? Road salt, what else? So sidewalks, so kind of like winter de-icing salts. What else? Water softeners. You see those giant bags of salt outside gas stations, right? We put it in our water softeners. Wastewater treatment plants cannot pull that out, so it all ends up in our fresh water. And I heard someone say fertilizers, right? This is something that we haven't spent a lot of time looking at so far, but potassium chloride, so KCl, is a source of chloride also into our groundwater. So sodium chloride, I used to be a chemistry teacher, so I get to nerd out just a little bit here. NaCl forms this nice little kind of grid here. We've got these like mini spheres. They're connected to one another, sharing electrons, getting those, that's why those charges come up. They like to hang out by one another, right? As does water. So this is our H2O, right? Water molecules like to bind up really close to one another, hang out. But when these two interact, when we put salt in water, the water molecules give giant bear hugs to the sodium and chloride, right? And then they don't let go. They love being by one another. And so we form these little associations where you have a water molecule giving those hugs to the chlorides. And that's why we say salt is a permanent pollutant in our water. Those water molecules hold on to the salt, or the portions of the salt, the sodium and the chloride, and they won't let go. It takes a lot of energy to pry them out, right? So we can do that with reverse osmosis, but it takes so much energy that it's practically impossible, right? It's not economically feasible to do that with our wastewater. And the only way to do that with our streams would, like, filter everything out of them, right? So we're not going to take it out. So how can we reduce the amount that's coming in? And I got to click over here. All right, so salty streams. mountains of salt. You guys all shouted out right away, coming in from road salt, those de-icing salts ending up in our water. So look at the numbers. Come over here. Thank you. So getting some help. Thank you. Yahara Lakes in the Madison area, very well studied, right? We don't necessarily have this amount of data on other water bodies, although Katie here from the Milwaukee River Keeper has been working to change that in the Milwaukee area, leading up citizen science monitoring, looking at chloride levels in the Milwaukee River Basin. But in the Madison area, when the city said, okay, yeah, we can start putting salt down on roads, let's do that and make sure, you know, people can drive where they need to go in the winter. But some members of the city council with a lot of forethought said, well, if we're gonna put all that salt down, maybe we should check what's happening with our lakes and start taking that into account. So this monitoring that began in the 1960s, surprise, surprise, has been allowing us to see that as we put more salt down year after year in these water bodies, in these watersheds, the lakes are absorbing that salt, right? And the chloride levels, so this is a measurement of chloride concentration, has continued to trend upward. If you're in the Madison area, if you were here, or maybe if you're here for the last talk that Phil gave, you might understand why Lake Wingra has more chloride or higher concentration of chloride than the other lakes. Does anybody think they might know why that is? Yeah. She's got it. Thank you. So Lake Window has less ability to dilute that water, right? The solution to pollution is dilution, right? To an extent. So Lake Window is the largest, has the greatest ability to dilute the water, or dilute the salt, excuse me, that's coming in. But we still see that now over 40 milligrams per liter. So, you know, we scale that up. Lake Michigan is receiving more than 1 million tons of salt. Yes, I will say that again, 1 million tons of salt going to Lake Michigan every year. Its chloride concentration is now at about 15 milligrams per liter. Larger body of water can dilute that, right? And I'll talk a little bit later though, that this isn't necessarily a measure of how much salt, like we don't see this equally distributed throughout the lake. And so that can cause some additional problems. So now scaling out to say this is not just a Madison problem, right? We have a lot of good data in the Madison area, but we see this across the state. So this is Linnea Rock. She's a student now in Wyoming, but did her master's at UW-Madison with Hillary Dugan. And she gathered this data from DNR USGS databases and has mapped out chloride concentration. So remember that one component, constituent of salt across the state. This is not necessarily due to like really comprehensive testing. It's not people going out trying to find peak concentrations. It's just some data, the data that we do have available right now. And you might see a few hot spots, right? So I invite you to talk to someone next to you. Why do you think we see some of the spatial trends that we observe here? What are they, I guess? What do you see and why? I want you to talk with someone next to you for a moment. If you're virtual, you can type in the chat. What do you see going on in that map? Yeah, you want to shout out now to the large group? Population, tell me more. Okay, so more people in southeastern Wisconsin, right? Milwaukee area, more impervious surface, more salt going down on that, right? So that is indeed where we see most of our highest concentrations of salt. Naturally in Wisconsin, we have very fresh water, right? Chloride concentration 0 to maybe 10, and we're not seeing that anymore across the state. I know these two purples kind of blend together, but we're seeing concentrations into the tens, the hundreds, and even the thousands of milligrams per liter. And we do have some chloride concentrations in the thousands of milligrams per liter in Dane County, right? My supervisor, Mike, will be sharing some of that data with you later. So that's not captured in this map. Like I said, it's not completely comprehensive, but it does show us that trend. We also see a little salinity plume coming out here, looks like from the south western corner of Marathon County that's actually coming out of Marshfield. And a little bit of drilling into this data has shown us that it's coming out of a little creek. So we, one of our audience members brought up, smaller water bodies, less ability to dilute the salt. It's coming out of a small creek right behind the Marshfield Clinic. So we see that a lot of times hospitals and clinics put down a lot of salt to completely make sure that winter surfaces are not an issue for people visiting the hospital. And so a lot of oversalting there, and that's all going into that creek. It just happened to be caught by the testing that's happening. We have a question, quick question? Yes. All right, sounds good. Maybe some more information to come here. So a little bit more data, hopefully not overwhelming at the end of a long day. Again, chloride concentrations here, milligrams per liter from 2018 through 2021. Now this is sewer pack data. So this is from Southeastern Wisconsin's Regional Planning Commission. And they've been doing chloride sampling for several years now. These are some grad samples. They're going to be sharing some more comprehensive data from this study in July. We have Laura Herrick from the Sewer Pack is going to be presenting during a SaltWise webinar. So I would encourage people who want to dig more into this to check that out. I see a question, quick question. Yeah. So for their region, yes, so you're going to get to hear a little bit more about that in just a bit. I'm probably getting in trouble for taking too many audience questions. But so what we can see here, so this is 500 milligrams per liter. So we're getting up to like close to 500, over 500 milligrams per liter. And even like, in the summer months, we're not dipping back down to zero anymore, right? So is that maybe a little concerning? What's going on there? So a lot of questions around, have we elevated the chloride concentrations in our soils, right? In our groundwater. So even in the summer months, now we're recharging our streams with salty water. But not to draw attention away from these huge spikes, right, into the thousands of milligrams per liter happening when we have those warm kind of snow melt days. So a lot of that salt now is like flushing into those creeks, high chloride loads. And these spikes are going way above and beyond this red dashed line. This is where the DNR currently has set an acute toxicity standard. The yellow dashed line is the chronic toxicity standard. So chronic toxicity, meaning if an organism's in water that salty over a period of time, it's going to do damage. Acute toxicity is more like the kill me fast. Like concentrations that high have immediate impacts on those organisms. What are those impacts? Well, we see here research of the University of Toledo, led by Dr. Bill Hintz, showing reduced rates of growth and reproduction, higher susceptibility to parasites. Salt is a stressor, right, on the bodies of organisms, just like our own bodies, right? If you're eating a really salty diet day after day, that's having impacts on you. The first impacts are observed when we have really young organisms that don't have a great ability to osmoregulate, right? They can't draw those salts out of their body. The first organisms, though, are tiny little guys, like our zooplankton, that really struggle. They're like little tiny like cucumbers, right? You put them in this salty water, so it turns into a pickle, cannot deal with that. So zooplankton populations begin to decline around 50 milligrams per liter. Again, this is research coming out of Bill Hintz's lab. So 50 milligrams per liter, well below that current threshold that the DNR has set. When these organisms begin to decline, it means it's less food, right? Going up the food chain. So we don't get as many of those game fish. This is actually Bill Hintz's brother-in-law. I stole his slide here with his permission. And then if we don't have so many zooplankton, a lot of you in the room are able to, put these food webs together. What does that mean? More algae, right? So in Bill Hintz's lab, they made little mesocosms, took buckets, increased the amount of salt in them, and they saw that as salt levels went up, zooplankton populations went down, algal populations went up. Water got greener and murkier. So I mentioned before that salt concentrations aren't necessarily going to be equal across a lake or, up and down throughout the water column. If the salt concentrations get really bad, which we've not seen this in Wisconsin, at least not yet, hopefully not coming too soon, but in upstate New York, and also I've heard of one lake in Minnesota that has gotten super, super salty. So that salt, remember, has the giant bear hugs by the water molecules. It makes that water heavy, right? So salt water is more dense. It sinks down. You can end up with a more kind of dense, heavy layer of cold water at the bottom of the lake that prevents the lake from naturally turning over. Lake turnover is very important, right? To the ecology of that ecosystem, to circulating water and nutrients throughout the water column. So this can have really severe impacts for the ecology of the lake. We also are seeing work coming out of the University of Maryland, Dr. Sujay Kaushal. He dives in real deep, if you want to get into this, in our recording from his SaltWise or Salt Awareness Week webinar that happened last January, looking at chemical cocktails. The idea that once we put sodium and chloride in our water, okay, so that we have those sodium and chloride ions in the water, they come through the soil, and clay particles that naturally are going to hold onto positively charged things, like our potassium or copper, manganese, things that are potentially nutrients for plants. Now you have sodium and chloride coming through. Chloride is negative, so that can pass through, but also the clay particles may let go of, release some of those other ions, and instead they're holding onto the sodium. So our soils can become more sodic, full of more sodium, fewer of those other nutrients that we might want in the soil, but now those things are released into our groundwater. We also see this happening in our infrastructure, right? So in Flint, Michigan, the lead crisis was exacerbated by the fact that they were drawing salty water from the Flint River. It led to more lead, those positively charged ions being released into the water. I told you, not good news to begin with, but now we get to move to some positive things. How am I doing for time? 5 minutes, all right, 5 minutes of solutions. So we've got people doing better mechanical removal, people capturing waste, salt brine from water softeners and using that to do their de-icing instead of bringing in more salts. We do a lot of education, so smart salting classes for operators at the municipal, county level, all the way down to contractors and school districts. This is an example of our winter maintenance manual. We work with municipalities to get a smart salting message out to residents. Videos, I think that's actually Phil Gabler's hand in that glove. Working on technical skills. So there's a winter snowplow rodeo. That's great, right? More mechanical removal means less chemical removal. Webinars happen every month. I already pointed out Katie in the audience. Her colleague Cheryl Nen is going to present on I guess that's in August. I didn't quite make it to the list. What Milwaukee Riverkeeper has been doing in terms of citizen science and local advocacy work. But these happen every month, and then they're archived on our YouTube channel. So resources for activists, citizens, operators, etc. Okay. A number of municipalities do a great job on social media, getting the message out. We produce a lot of social media content. So if your lake association or community wants to, tag us, like us, we appreciate that. So do the grantors. River Falls, I'm actually going to be doing an event like this in Stevens Point in a couple weeks during Public Works Week. Does an event with students, and they come out and they get to see local trucks and what the city's doing. And when they learn about the salt truck, there's a little 5-gallon bucket behind this gal. They talk about the fact that 1 teaspoon of salt is all that's needed to pollute 5 gallons of water. So they're teaching students about this issue and what's being done. And a lot of smiley faces. We've got a PSA, I don't think we'll watch it right now, with the city of Milwaukee, actually a couple of them that we're going to be running this coming fall and winter to talk about what the city is doing and how citizens can be a part of that. Oops. So a lot of BMPs I'm not going to talk about right now. Reducing chemicals by using mechanical removal, doing better calibration, really dialing in application rates and adjusting those based on pavement temperature. So really precise use of salt, and then sharing those learnings. So we host equipment open houses with municipalities and school districts. Anybody who's putting salt down, let's talk about what we're doing and how we can all do this better. So then we try to get the word out when we have those events, like in De Pere with Emily and her amazing community staff. So what can you do? I would ask that everybody in this room works to, adopt the best practices in their own homes, communities, spread the word with others, and then you can get involved with chloride monitoring. Addie and Katie would be excellent resources for that. I've got information up on our website. There's free monitoring strips available. Also, you can promote Salt Awareness Week every January. We have live streams and some in-person events. Mention social media. If you are a teacher or have connections to people who are in the classroom, we have resources for elementary school all the way up through high school students to talk about this work and have them really engage in inquiry science. This was the monitoring that I mentioned through the Isaac Walton League. They will send you a pack with free chloride test strips, and you can go out and monitor local streams. So I finished in time to pass it off to Mike. If you want to grab the QR code right now, that'll take you to our link tree and you can jump on the website or social media, but we'll be excited to take any questions afterwards.
We will do a quick transition here and get Mike up and write your questions down, put them in the chat, hold them in your brains, and we will do a long